All right, so this is another one of the nitro reactions. We're gonna transform this. I don't know. I'm saying transform. We're gonna make this cyano group into a ketone. So you could look on the top right. That's what the answer is gonna be. So yeah, there's like two parts to this. The first part we're gonna make the amine. We're gonna make not the amine. We're gonna make the imine, and then the next part we're gonna turn that imine into a ketone. So yeah, so this is how it's gonna go. We're gonna go from E rich to E poor. So this we're gonna do a nucleophilic addition on the carbon right here, and yep, it's two steps. pH double, and the negative is on that, and now we have this methyl right here. Now, if you look at the bottom right here, there's hydronium in the flask. So we're gonna just do acid base, and we'll form the amine. Okay, that's the amine. Now we have to do the acid workup. So I want you to think about this. Is how I want you guys to think about this question, because there's a lot of water. There's like water. There's hydronium. There's this acid. There's this that. Who the hell is gonna be doing the attacking? Okay, so first off, since we're doing an acid workup, I don't want to see any negative charges. So if you end up doing the mechanism, you get a negative charge. You're doing something wrong. Okay. Second thing. So that means we're not gonna be doing any like okay, you have like okay, let's start this reaction. You have water, like this is how I'm doing it. Like is water gonna attack? Is hydronium gonna be attacked? Or is OH minus gonna be attacking? First off, there's no OH minus in the flask, so we cross that out. Is this gonna be doing this? And then we're gonna form this? Or are we gonna have, let me use a different color. Or is this okay, first off, I should have been more clear. This nitrogen has a H, and this has an H as well. It has a lone pair. Okay, so or is this gonna happen? So since we're in an acidic environment, if we do this, we're gonna get a negative. We're gonna get a negative on nitrogen. So we're gonna go with hydronium. So hydronium is gonna be getting attacked. So let's do it right here. pH. And second off, this is most important. This is actually what I meant to say. Why the hell would water attack? Like, there's no reason for it to attack. The only time you'll see water attacking something is if this had a plus charge. Because first off, water is so neutral. There's no reason for it to be attacking it unless there's a positive charge on the carbon, because the carbon already is electron poor, right? Or not even poor. It's just like it's gonna be attacked. Whatever. No charge. Water is not gonna be attacking. Okay, that's the most important thing. Because I was doing this reaction by myself, I made that mistake. So that's not gonna happen. So yeah, we're gonna put that on nitrogen, and nitrogen's gonna have, yeah. So cross this out, okay? Cross this whole crap out. All right, it's not happening. So nitrogen now has a plus charge. Okay, so um, now that nitrogen has a plus charge, it's a delocalized charge. So now, um, we can form resonance structure. So just push this. I'm gonna be consistent, and I'm gonna be fast. I'm taking a little bit too long. How much? What are we on time? 4 minutes. Damn. All right, I gotta go quick. Okay, so move electrons to this, that. Yep. No, actually, it's the other way. We're gonna move it to this. We're gonna move electrons towards the positive charge. Okay, not the other way. I'm bugging. And nitrogen has H, and he is good now. You know, he's fine. Now we have the charge. Now who's gonna be doing the attacking? Water is gonna be doing the attacking, because I told you about the plus charge. Once you see the plus charge, water is gonna be doing attacking. So, bam. Maybe I should just put it here. Honestly, I don't know why I'm being so lazy. All right, pH. And now we'll have water doing attack. So now water does the attack, but water only wants 2 bonds. He now has a plus charge. So who the hell is gonna take that charge off him? We have a lot of water. We're gonna add a lot of water so we could push the reaction to the right. Okay, so we're gonna add more water. So water's gonna be doing that attacking. He's gonna take that H. Let me use red. Yeah, he's gonna take that H. So now, what's our goal? Okay, I don't want you to be doing these mechanisms like blind. Like you need to have a goal. Like what's the point? We're trying to make a ketone, right? So we're almost there. We have the O for the ketone. It's ready. We just need to do one. We just got to do a couple more steps. In a ketone, is there N? Nah, there's no N. So we got to get him out of here. So how are we gonna do it? We just formed hydronium. Hydronium is now in the like it's already hydronium. Okay, first off, I don't even think that's true. Like how we're forming something. It's just that hydronium is in the flask. H2SO4 and hydronium. So hydronium's gonna be there, and we need to be able to make nitrogen like have a plus charge. We need to pronate him. We need to do acid base so he could leave without getting a charge on him. Okay, so now nitrogen's now gonna have a plus charge, and so now nitrogen has a plus charge. He is now able to leave. He's a good leaving group without him getting a negative charge. So he's gonna get the hell out of here. So this is how we're gonna do it. You could either do resonance. You could do resonance and then make him leave, or you could just do one step, like just do quickly. Boom, boom. He's out of here. So now we have this, and now we're literally at our ketone. So now that we push the double bond on here, now what are we gonna do? We have this H. Maybe more clear. Oxygen only wants 2 bonds. So we're literally look at the structure we have. We're literally at the answer. What are we gonna do? Who's gonna depronate him? The water. We have a lot of water, right? So water is gonna be taking away that H. So now water can come in, and water is gonna where is it? Where's the H? Maybe water is gonna take the H, and now we form our ketone. And remember to regenerate your acid catalyst. And that's it. Listen, the thing about the plus charge, that is a like a hack, okay? If you understand about that plus charge, one water attacks plus charge. In general, I mean that's not a general thing, but like in most of these reactions, that's what's gonna happen. Like think about who's gonna be doing the attacking, what's gonna be attacking. Are we in acid? Are we in base? What kind of environment are we? If you're able to think about it, then you can figure out these problems on the fly. You don't need to memorize it.